All right, this topic's called Properties of Quadrilaterals. Basically what I'm going to do is I'm just going to go through each of the four-sided figures because that's what a quadrilateral is. What you need to do is take out your notes and write these down. I definitely want to see these in your notes, and the other thing I have to offer you is a handout that, besides having them in your notes in a list formation, mine is kind of like a Venn diagram that I can show you that might also be handy. And having both of these, I think, is a pretty good way to kind of keep them straight in your mind and learn it from two different perspectives. So it's definitely a good thing to do. All right, so take your notebooks out. First thing I'm going to do is define what a quadrilateral is. That is just a four-sided polygon. I won't talk about what the actual definition for a polygon is, or I won't write it down, but polygon is it's a figure that is closed, so it has no open gaps in it, and it has to have more than two sides. That's the basic. It can have no rounded edges, only segments. So a circle is not a polygon, but you can look at my video about polygons, and that will tell you more. The first quadrilateral that I want to talk about is the parallelogram. And this is a lot to write. Mathematicians do not like to write things, so they came up with a symbol, and it's kind of just like a little parallelogram with a P in it. That's how you write it. It saves you a lot of words, and then like, wait, is it two L's here, one there? Is it two L's in both places? You know, just all that confusion that can be so defeating. Okay, so what are some of the properties of parallelograms? Both pairs of opposite sides are congruent. I'm going to abbreviate opposite. And I'm not going to write out the word congruent. By now you should know that that is congruent, the equal sign with the squiggle on top of it. Not only are both pairs of opposite sides congruent, but both pairs of opposite angles are congruent. In a minute I'll draw a parallelogram with it all marked up. Oops, I wrote sides again because I was yapping and writing at the same time. That'll do it. They are congruent. So both sides of opposite sides are congruent. Both pairs of opposite angles are congruent. Both pairs of, I'm getting tired, ditto marks. Both pairs of opposite sides are parallel. This is the symbol for parallel. Hopefully you've learned that when we talked about parallel things. The diagonals bisect each other. I'll draw those in a minute too. Diagonals. They don't have a symbol for diagonals that I know of. Diagonals bisect. If you've reached properties of quadrilaterals, you hopefully have already gone through what the word bisect means. Bisect is just a fancy way of saying split in half, but you can say it in one word, bisect, instead of split in half. Okay. And another thing that is a good thing to note is that one pair of opposite sides are parallel and congruent. That doesn't make sense for a parallelogram. One pair of opposite sides. Oh, alright, that's how you prove it. All these things I'm listing, not only are they properties of quadrilaterals, they're also another way to prove. Like if someone gives you a four-sided figure and it's got like all kinds of tick marks and stuff, you can use any one of these different statements to prove that it's a parallelogram. So if all the tick marks show you that both pair of opposite sides are congruent, bam, you can immediately conclude that it's a parallelogram. If all the tick marks and markings up on the quadrilateral that they show you prove that both pairs of opposite angles are congruent, you can say it's a parallelogram without any squeaminess. Or if you can show that both pairs of opposite sides are parallel, that's another way to prove that some kind of a four-sided figure is a parallelogram. In other words, you might just be walking down a street, some dude taps you on the shoulder and shows you a picture of a four-sided figure. What is this? These are the things you would look for on anything he's drawn in it to say that, oh, that's a parallelogram. How do you know that? Oh, because you have that shown here that both pairs of opposite angles are congruent. And this other thing, diagonals bisect each other. Again, if they showed you a four-sided figure and the diagonals were bisecting each other, you would be able to say it's a parallelogram. The final way to prove that something is a parallelogram is one pair of opposite sides is both congruent and parallel. And parallel. Whoops, that's equal. My parallel symbol got a little tired and wanted a nap. So let me draw some pictures. You got all that written down? If not, hit pause. So these are ways to prove that a quadrilateral is congruent. So scrolly uppy. We'll go through them from top to bottom. If you have room in your notes, what I would do is next to the words both pair of opposite sides congruent, I would draw this picture next to it. So for both pair of opposite sides, if someone walks up to you, and again, never trust that it's drawn to scale. I could draw this horrendous thing, it still has 4 sides, but if I do that these guys are congruent and these guys are congruent, you can say, Howard, I know that's a parallelogram because opposite sides, both of them are congruent to each other. Bam. Alright, so that goes with this guy. The second one, both pairs of opposite angles are congruent. So if that homeless guy walking down the street of Greenfield shows you this picture, and he's like, dude, I'll let you buy me a cup of coffee if you can tell me what kind of quadrilateral this is. And you look at this guy here and you're like, clearly it is a parallelogram. And he'd be like, how did you know that? Well, if both pairs of opposite angles, see how they're across from each other, are congruent, it has to be a parallelogram. You will get to buy that man a cup of coffee, assuming you have money. And, you know, there's a coffee shop nearby. All right, I'm going to scroll it up, and we'll talk about the third way, which is both pairs of opposite sides are parallel. Not sure if you know this or not, depending on what videos you've watched before, but how do you show that a side is parallel? So, again, this time we'll have our awesome bag lady in Greenfield. She came up off the bank of the river, was about to hop on her bike, and she saw you, and she's like, I will give you one of my bags if, and she hands you this picture, like so, if you can tell me what kind of 4-sided figure this is. And you would just like look at it and be like, all right, be prepared to be blown away. I got this opposite side and this opposite side. Those 2 arrows mean they're parallel. Same thing with these 2 opposite sides. They are parallel because those 2 little arrows tell me that. Since both pairs of opposite sides are parallel, it's got to be a parallelogram. No ifs, ands, or buts. You will just knock her socks off. Well, not sure she wears socks, but you will just stun her, and she will give you one of her bags. Maybe she'll autograph it. Probably you would make some money because she's pretty famous. All right, the next one, diagonals bisect each other. What would this look like? Again, we have a 4-sided figure. So here's one diagonal. There's only one other diagonal in a 4-sided figure. How could you tell they bisect each other? Well, it means that this guy here is split in half, so those 2 chunks are equal. And this guy here is split in half, so those 2 chunks are equal. We're not saying that all 4 chunks are equal. We're just saying that one diagonal got chunked in half, and the other diagonal got chunked in half. So if someone, you know, if you were on like Wheel of Fortune and they like, please identify this figure, you would win whatever money you needed to. Actually, that would probably be more like a Jeopardy question. And Alex, the answer is, what is a parallelogram? And you would win some cash, and everybody would want to be your friend and borrow money. All right, we're down to the last one. What would it look like if one pair of opposite sides was both congruent and parallel? All right, what that would look like is this guy. Same old 4-sided figure, wahoo. We would have our little parallel markings, and we would have tick marks to show that they're congruent. So these are opposite sides. They're across from each other. They are parallel, and they are congruent. I guess I like drawing circles. All right, so that's what it would look like for parallelograms. Next up will be our rectangles. All right, I did parallelograms first for a reason, because most quadrilaterals are parallelograms. Not all of them, but most of them. So the other ones that we're going to talk about next start with the facts that they are parallelograms. So you might have to identify that something is a parallelogram and then look and see if there's any other clues. So let me get rid of this and write rectangles at the top. All right, so the next quadrilateral, rectangles, you're getting this all in your notes, right? Right. There is not a symbol for rectangles. So, yeah, just have to write it out. Sorry. What could you say was a rectangle? Well, if someone showed you a parallelogram, yeah, I'm not writing that out, with one right angle. I'll draw the picture next to it this time. So let's say, and again, I'm going to kind of draw it, making it look squirrely, because part of geometry is not trusting what your eyes see. It's looking for tick marks and things that are marked up on your picture and trying to figure out what are the correct conclusions to come to. So these don't really look like any of the angles are right, but I'm going to go shoom. And then let's say that I also have these guys. All right, so we know it's a parallelogram because we have opposite pairs of sides are congruent. Those are all the tick marks showing that. Then we have one right angle. So not only is it a parallelogram, but it's also a rectangle. That's the most specific thing it is. We can't say it's a square because we don't know that all four sides are congruent. So we can't go that far. Another example for a rectangle is if we have a parallelogram with diagonals congruent. I touched on this quickly in one of the last pictures I drew. Again, here's my parallelogram. I am going to say that this guy here. What did we learn about parallelograms? Well, we know that they bisect each other. But in this case, if I am shown this picture, not only is this chunk equal to this chunk, and this chunk equal to this chunk, which is a clear signal that we're talking about parallelograms, but all four chunks are equal to each other, bam, we have to have a rectangle. Got to happen. Alright, next one is if you are shown a four-sided figure, so you have a quadrilateral, and all four sides are congruent, it has to be, I'm sorry, for all four angles. There, erase that. All four angles are congruent. Has to be a parallelogram. I'm sorry, has to be a rectangle. Why is that true? Because all of the quadrilaterals, the angles inside of them add up to 360. You know how triangles add up to 180? Quads add up to 360. So if you have four angles that when you add them together equal to 360, but they're showing that all four are congruent, they all got to be 90-degree angles, so it definitely has to be a rectangle. In this case, we can't say that it's a square yet because we know squares have right angles. We don't know enough about the sides. So we can't definitively say it's a square because of that reason. They didn't give us any info. We're just stuck. We see the four right angles, bam. Even though they didn't mark them as right, we have to conclude that 360 divided by 4 equal parts is 90 degrees. So that's what we can conclude, but we can't conclude that it's a square. One more thing that will help us show that we have a rectangle when we're showing a four-sided figure, and that is that we have a quadrilateral, I'm going to abbreviate, with at least one right angle, with at least one right angle, and all other, it's almost like the same one above, all other angles are congruent. It's almost the same deal as this guy. Very, very similar. It's just that it might look a little different. So if someone was betting you money and like you got this third one here correct, they'd be like, ha, I'll mess you up now. Watch this. But again, it's the same reasoning. They have to add up to 360. We know one of them is 90 degrees. So if we take that guy out, that gives us 270. Split that 3 even ways because those 3 are all congruent. And what is 270 divided by 3? Oh my gosh, it's 90 degrees. So again, it's a little bit of interpretive thinking. That's what this topic's all about. We're looking at the pictures, what's marked up, what can we conclude about what's marked up, and then we're going from there.